In this video, we're going to explore how to classify different triangles and then how to find the value of a missing angle in a triangle. So the first part here asks us to classify the triangles below by side and angle. And this is a pretty important concept to understand, and that is that there are two different ways to classify triangles. We can classify them by the lengths of their sides, or we can classify them by the size of their angles. And so what we'll do is we'll focus on the side lengths first, and then we'll focus on the angle measures next. So I have three different triangles here. I have a blue triangle, a green triangle, and an orange triangle. So the blue triangle, so when we're focusing on the lengths of the sides, we can either have specific side measurements, or we can have these little markings that have occurred. And what these little markings tell us is the relative length of the different sides. So for instance, on the blue triangle, we have this one mark here and one mark here, which tells us that those two sides are the same length. Now the third side has two markings, which just tells us that it's different than the other two. We don't know if it's longer or shorter per se, but we know that it's not the same length. So what we have here is we have a triangle that has two sides that are the same length and one side that is different. And so this is an isosceles triangle. So remember, an isosceles triangle means that it has two equal or congruent sides. Now we'll look at the green triangle here, and we'll focus on those markings again. This time you can see that there are 1, 2, 3 sides that all have the same marking. So what that tells us is that all three sides are the same, or that this is an equilateral triangle. So equilateral. And if you think about the word there, equa means equal and lateral means sides, so it means that it has all sides or three congruent sides. The orange triangle, you'll notice, has one side with one marking, one side with two markings, and one side with three markings. So all three sides are different, so that's what we call a scalene triangle, which means that there are no congruent sides. Okay, no sides are equal. So those are the three choices for classifying a triangle by side, but as you saw, we can also classify them by angles. And so what we're looking for here is we're looking for the presence of different types of angles. So we'll focus on the blue triangle first, our isosceles triangle. And what you'll see here is that up top we have an acute angle, and over here we have an acute angle, and then right here we have a right angle indicated by that little right angle square. So as long as you see a right angle, that tells us that you have what's called a right triangle. So this is a right triangle, and we know that because of the presence of a right angle. I'm going to jump to the orange triangle next, and the orange one we can see that we have once again an acute, another acute angle, and then we have a big obtuse angle here. So because there is a single obtuse angle, this is what is called an obtuse triangle because of a single obtuse angle in the triangle. Now if you look at the equilateral triangle here, you'll also notice that we have three angles, and they are 1, 2, 3 acute angles. And so because there are only acute angles, this is what is called an acute triangle. And it's important for this one that we recognize it's because there are only acute angles. There's nothing else. Right? If you look at all three triangles, you'll see that all three of them have acute angles, but the acute triangle is the only one that has all three angles being acute. Now, another thing that's worth noting about different types of triangles is that by focusing on the side definitions, that also gives you information about the angles. And so for example here, if you look at the equilateral triangle in the middle, because there are 3 equal sides, it also means that there are 3 congruent angles. So if all 3 sides are equal, therefore all 3 angles are equal. The blue triangle, which has 2 congruent sides, also has 2 congruent angles. So because 2 sides are the same length, therefore 2 angles have to be the same size. And finally, the scalene triangle has no congruent sides, so it has no congruent angles. And that can be helpful for us when we're trying to find the values of missing angles in a triangle. For the second part of this video, we're going to look at how to find the value of a missing angle. And the key here really is that understanding that in a triangle, angle 1 plus angle 2 plus angle 3 always is going to equal 180 degrees. This is something that is true for all triangles. Every triangle, the sum of the angles is 180 degrees. So the triangle that we have at the bottom here has an angle measure of 38 degrees, 23 degrees, and x degrees. So the first thing I'm going to do is I'm going to try to find the value of x. And so to do that, I'm just going to actually substitute in some values here. I'm going to say angle 1 is 38 degrees plus 23 degrees plus x degrees equals 180. And now I'm just going to do some equation solving like I do before. 38 plus 23 is 61 degrees plus x equals 180 degrees. Oh, I forgot my 0 there. And now I'm going to subtract 61 from both sides. Minus 61 minus 61. Cancel that out. X equals 119 degrees. So I can actually write that in. This is 119 degrees. And just out of curiosity here, we can now actually classify this. And we know that because of this one obtuse angle, that this is an obtuse triangle. And we also know because all 1, 2, 3 angles are different, it is therefore also a scalene triangle. So without even knowing the length of the sides, we can figure that it's scalene because all the angles are different.